Hey guys, and welcome back to a new Jetpack Compose tutorial. In this tutorial, I will show you how you can implement a pull-to-refresh mechanism in your app. So very often we have a list of data, and when we pull down, we would like to refresh that data and reload it from the API or database or whatever you're using. So if I leave this here, you can see we see this little loading bubble, and after a little delay, the list will reload. In this case, it's really just a sample list, but I will show you how you can really react to these refresh events, how you can then also refresh data from the API, or at least where you would need to put the API request, and also how you can add a button to force refresh without needing to pull down. And in the past, I've already done a video about that with the old accompanist library, but that sadly gets deprecated pretty quickly. So here you have an update with the official Compose version of implementing this. Because I think Compose really did not solve this in a very intuitive way. Here a video so you can understand how this works. The first thing you need to make sure if you are in an empty Android Studio project is to dive into your build.gradle app file and update this Compose BOM version to, ideally the same one, but at least this version, since as of now with Android Studio Hedgehog, the default version does not support this pull-to-refresh composable that we need here. If you sync this, then you are good to go, and you can pretty much just go to your root package and create a pull-to-refresh LazyColumn. That is what we will build here, since usually if you have a pull-to-refresh gesture, then you want to have that together with the LazyColumn. Not always, but in most cases. So I just want to have a generic container which abstracts out all the functionality we don't need when we want to use such a pull-to-refresh gesture in a list. So we want to have this pull-to-refresh LazyColumn. And this is a generic function which takes in type T, which is the type of items we have in the list we show in this LazyColumn. So items is a list of T. And each item has some kind of composable content that we would like to show. So just a composable lambda. Each item, actually not each item, but the whole list has a state, whether it's currently refreshing or not. So whether to show this loading indicator or not. We want to have a lambda on refresh that gets triggered when we are actually refreshing. So that would be the lambda we would remake our API call or so. We'd like to be able to pass in an optional modifier like this. And we would like to be able to pass in a lazy list state from the outside, which is the default, remember, lazy list state. So just if you would like to pass some state to the LazyColumn, we want to be able to do that. And the first thing we need is a pull-to-refresh state. Pull-to-refresh, so just like when creating a LazyColumn, we can also create such a pull-to-refresh state that lets us control our pull-to-refresh configuration kind of. So remember, pull-to-refresh state, there we go. I'll enter to opt into this experimental API. And then we actually need to put in our LazyColumn in a box composable or a column or any type of container pretty much, because we need to connect this container of our LazyColumn with this pull-to-refresh state. And we do this with a nested scroll connection. So we just use this to communicate the scroll information when we try to swipe down, that the indicator is actually displayed at the right position, that the animation properly plays for that loading indicator, and so on. For all that, we need this nested scroll connection. Luckily, we don't need to create that on our own, but rather refer to the nested scroll connection from our pull-to-refresh state. And inside this box, we can then create our LazyColumn. So, what am I doing here? We have a LazyColumn here. We'd like to be able to pass in our lazy list state. Lazy list state. Let's say we have some content padding of padding values ATP. All these are, of course, values you could also easily provide from the outside, but you usually would want to keep flexible for a LazyColumn. You could also want to pass in a modifier. We say, hey, we actually want to fill the whole size of our screen, or at least of the parent composable. And let's say we want to have some spacing between each item. So vertical arrangement is arrangement that's spaced by ATP. And then inside here, we can define which items our LazyColumn actually needs. We do that with an items block. Make sure to use this overload that takes in a list, since we have a list of items here. So this function just loops over all of our items, gives us a reference to each item, which we can then put in our content composable. I actually didn't provide that as a parameter here. So let's put in T here. Since, depending on what kind of item type that is, we might want to show different content. And since you would like to have a generic pull-to-refresh LazyColumn that doesn't just work for one type of list, we have a generic parameter that allows us to use this for any LazyColumn. And so far, we haven't used this pull-to-refresh state yet. So we have assigned this to our nested scroll, but we don't really have any mechanism that tells this pull-to-refresh state that we should really show this indicator when we're swiping. And that happens below our LazyColumn with a so-called pull-to-refresh container. That takes in our pull-to-refresh state and also lets us configure this a little bit more. So, for example, the modifier is something we would want to override, since we would like to align this in the top center. So just making sure that the indicator really displays at the top center and not somewhere at the bottom or so. And other than that, you could also change the indicator itself. So if you have a custom indicator, if you're not fine with the default from Android, you can change this to your own composable. You can change the shape of the indicator. You can change the color. And that's pretty much it. Okay, so far we've connected our pull-to-refresh state with our container and with our root composable, with our box. But as you can see, what's currently missing is that we listen to this is refreshing Boolean, since if this changes from false to true, for example, we would want to start a refresh for our LazyColumn. If it switches from true to false, we want to stop the refresh and also call this on refresh lambda when we are actually refreshing. And this modifier actually also isn't used. I want to use this here. So we're fine with that. So let's take a look how we now do what I just talked about. If our pull-to-refresh state that is refreshing, so the state just contains all the information we might want to know about when it's about pull-to-refresh. So you also see the positional threshold, the progress, the vertical offset. So if you might want to animate something else, depending on how far the user swiped the indicator down, then you can also listen to things like the vertical offset and perform some kind of other movement or so. We really only care about is refreshing, end refresh, and start refresh. So with these two functions, we can do exactly what they say. And is refreshing is just the Boolean state we can listen to when that actually changes. So in here, if we have a launched effect block with a key of true, so we just fire this launched effect block once, but once every time this state changes, since then this launched effect composable will be put on our screen again, and it will just run once. In that case, we just call on refresh. What we also need is another launched effect block down here with our is refreshing Boolean, since when that changes, that is the Boolean we pass from the outside, then we want to trigger the actual refresh. So if is refreshing, so if we change that from false to true, then we want to use our pull-to-refresh state and start the refresh. And otherwise, we say pull-to-refresh state and refresh. So that is how we really trigger these changes. If the pull-to-refresh state could change, we could also pass it as a key here. But since we initialize this directly inside the composable and don't allow to pass this from the outside, this can never change since it's a val in here. And now let's see how we can use this composable, since that now contains all the functionality we need. Here in our surface, let's just have a list of items equal to remember, doesn't need to be compose state, really just a list of items, a static list that we display here. Could be a list of 100 items, map them to, I don't know, item and the corresponding number of that item. We will have a state is refreshing by remember mutable state of false initially. So this will just show when we are refreshing the list, otherwise it will just be false. Normally all that would be put in a view model, of course, but here for this simple tutorial, let's put it in our UI. And let's have a little coroutine scope just to simulate our little network call with a delay. So we can say, remember coroutine scope. And in here, we can then have a box, since in our UI, if we take a look here again, we have our LazyColumn, and at the bottom, we want to display a little button that can force trigger our refresh without us needing to swipe. So this box has a modifier of fill max size. And in here, we first of all want to have our pull-to-refresh LazyColumn. The items are our items we've created before. The content now gives us a reference to each item, which in this case is a string. So item title or so. Here we could just show a little text composable with this item title Also maybe add some padding. Modifier.padding 16 dp or so. Alt-Enter, import that. Format this a little bit. Is refreshing is equal to our is refreshing state. And when we are now refreshing, so when we actually trigger the refresh, then we want to launch our coroutine. So normally you would again delegate this call to the view model, which would then fire the API call again, which would reload that data. But in this case, let's just say is refreshing is now true. Then we delay this by, let's say, 3 seconds, and then is refreshing is false. This is really just the simulated API call. And for as long as that API call takes, we just leave is refreshing to true. So as long as that is actually going on, we also show our indicator. Let's also quickly add our button down below. Here, button on click should now just set is refreshing to true. We add a little text, say refresh. And by just switching this is refreshing state to true, that will trigger our launched effect block here. Since is refreshing changed, then it will check, okay, is refreshing, that's true. So we start the refresh with our pull-to-refresh state. That will change the is refreshing state of our pull-to-refresh state. So that's a different Boolean, which will then fire off this launched effect block. And finally also this on refresh lambda. That will then just again trigger here, set this refreshing to true again. In this case, it's already true, so this line will not do anything, but it will fire off our API call and then set it back to false afterwards. So if we launch this, hopefully that should work. And you will see I apparently forgot to align this refresh button, but that shouldn't keep us back from trying this out. Let's pull down, you can see that's the indicator, and it will show up for exactly 3 seconds and then disappear. There we go. If we click refresh, then the same should happen. And yes, that's exactly the case. If you would want to align this, you could simply add a modifier here. Is modifier align, align bottom center, like this. And then it's also jumps to the bottom. So that's how you create a pull-to-refresh gesture in Jetpack Compose natively without any accompanist library. While Compose is really great, it's also very easy to make mistakes with it. Thanks to all these complex effect handlers we can use, thanks to all these performance hacks we often need to apply in order to make it run smoothly. I've combined all these important and crucial mistakes into one PDF, which you can download for completely free by clicking the first link in this video's description. So check that out, download it, and happy learning. Other than that, thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.